Hello, looks like my recording got cut off and my discussion of function composition was not included. So let me review what I said, and nobody was listening. But I'll just go over these notes. You should have access to these notes. These are the OneNote notes that you have the link for. So function composition means you take one function and follow by another function. And there are some problems that ask you to show properties of function composition. So this one here is 8.6. Let me see if I can locate exactly what it is. There's an assignment here, and it's the assignment that is 8.6. I think it's we could look at this 11 ACE. Let's see. Oh yeah, here we go. 8.6.18. So I did C for you, and I do think a good way to attack these is to first draw a picture and see why the property is true. All right. So this one is asking you to show that if G composed F is onto, then G is onto. Right. So here's the picture. What is G composed F? Well, it's F followed by G. It's funny that F goes first and G goes second, and you write it as G composed F. But you're used to that with functions. G composed F means the same thing as G of F, right? So you can write G composed F this way. You can also write it this way, G of F of A. All right, so I've drawn a picture here of how these functions work. Here are my three sets ABC. My function F goes from A to B, function G goes from B to C. And the composition goes from A all the way to C. Right? So A, apply F, F gives me F of A, apply G, you get G of F of A. And that's the same thing as G composed F of A. Okay. I want to show that G is onto, given that G composed F is onto. All right, now what does that mean? You should always go back to the definition. Given any C in capital C, which is the final codomain, you need to show that there is there is a B in this middle set, such that G of B equals C. That's what onto means. It means that every element in C has an arrow pointing into it from B. Now what do we know? We know G composed F is onto. So we know we can get from the set A to every element of C. Now, this property shouldn't be surprising, because to get from A to C, you have to pass through B. So if you can get from A to C, you should certainly be able to get from B to C. So that's the idea. And that's the strategy. I'm going to try to establish this statement, given any C in little c and big C, and I need to show that there is a little b in big B. So, and I'm going to use this property that G composed F is onto. All right. So this is what I need to show. Right. So the proof. All right. So first I have to give this condition, given any C in C, and I need to show that there is a B such that G of B is C. Now, since G composed F is onto, there exists an A such that G composed F of A equals C. All right. That's the definition. That's a small c. Okay. Sorry about the poor writing. Okay. All right. All right. So you can find an A that maps to C. All right. But then A also maps to an element of B. All right. So I let B be F of A. Then B, a little b, of course, is in big B, because since big B is the codomain of F, and G of little b is G of F of A, and that's the same thing as G composed F of A, and that's C. Okay. So we've established this fact here, that there exists a B in big B such that G of B equals C. So that establishes the necessary premise. Okay. So I put this in red because it's something that's very important to remember, that G composed F of A is the same thing as G of F of A. It's the very same thing. Okay? Okay, good. Well, I guess that's all that we missed, but I thought that might be helpful for you to get that little snippet there.